Minerals grow in different ways. One way is solidification from a melt. Solidification from a melt. This rock here is a basalt. There's ropey, swirly formations. That is called a pahoehoe basalt. And the basalt, even though you can't see the crystals, is made up of minerals that are teeny tiny microscopic crystals. And the crystals are going to grow when that molten rock cools and they crystallize. The minerals also can precipitate from a solution. This is the bottom of Death Valley. In Death Valley, you'll have water come in and flood the flat basin, and then that water will evaporate and leave behind these evaporites, different kinds of salts and gypsums that precipitate out of solution as the water evaporates. There's also solid state diffusion. This happens during metamorphism. We'll have a whole chapter on metamorphism later. Metamorphism happens when there is a change in the mineralogy or the texture of a rock due to heat or circulating fluids or pressure. These garnets grew during metamorphism and there was no melt. They were just solid state diffusion and changed from one, probably like clay minerals, into these big garnets. Metamorphism is solid state diffusion and growing those new minerals. We can also have biomineralization. Remember, minerals is its own thing. We can have synthetic minerals that are man-made minerals or minerals through biogenesis, so biogenic minerals. And here is a skeleton of a T-Rex. And if you look at those bones, they're different aragonite crystals that have grown together into a bone structure. So they are, that's biomineralization, so in that fossil. There are minerals that can grow directly from gas. This is a vent from, say, near a volcano or a mantle, a magma chamber, and the vent is pumping out sulfuric acid, and some of that acid is precipitating, some of that sulfur is precipitating around the rim of that vent. So those are sulfur crystals on a vent, maybe coming up from a magma chamber, or and it's maybe associated with a volcano. All right, so the formation of crystals happens, move my face. There'll be the beginning of crystallization, maybe a layer of atoms form, and then it's going to grow out from that layer. So in this case on the left, maybe there's a void space, maybe a geode. The outside grows first, and then it's going to slowly crystallize as it closes in that void space. So the outside of this void, I guess that would be the inside, is the newest part, and the oldest part would be the rim around it. So over time then, going to the next block, that void space can fill up as atoms attach to the crystal faces. So I have here a crystal. This is a quartz cluster, and so if we turn it around to the back, this is the oldest part of the crystal. The newest part of the crystal would be the outside of these crystal faces. Okay, this is just showing that growth. If we start with a magma and start to cool down the magma, different minerals are going to crystallize at different temperatures. So here's 5 different crystals that are growing as atoms attached to the outside of the crystal faces. Over time, as they grow, they're going to coalesce into a mass of crystals. That's why in, say, a granite, we don't really see the crystal faces. It's because they've all grown together as that magma solidifies. Here is a geode, kind of like the one that I was showing, where the outside is going to be the oldest, and then as it grows into a void space, the very tips of these crystals and the crystal faces are the youngest part of that sample. In this example too, these crystals, and this is an amethyst, and this is also, which is a kind of quartz, those are called euhedral. Euhedral, that prefix "u" means good, so those are good crystal faces. "An" means not, so there's no crystal faces. So we would look at a crystal and say, is it anhedral or euhedral, depending on how well you can see those crystal faces. So the example here is a euhedral crystal. We can see those crystal faces. How is a mineral destroyed? We can remelt a mineral, so melting is going to break those bonds, becomes a liquid, and now we no longer have those crystals. A crystal can also dissolve. Usually it's water can dissolve crystals. Something like quartz needs a really high-powered acid, like hydrofluoric acid. We can dissolve quartz, but naturally it would be very slow to dissolve quartz, but you need an acid for that. So dissolution of those crystals. There also can be chemical reactions that break the bonds and form new bonds. So minerals can get formed and they can also be destroyed in different ways.